Hey, all you cool cats and kittens. Welcome to Math with Coffee. I'm your host, Mrs. Coffee, and today we're going to learn about volume. That's exciting, I know. Yeah, volume is super important because it's got a lot of real world applications. For example, if you needed to figure out how much sardine oil was in a cylindrical can, you would use the volume formula of a cylinder to calculate it. And there's many other applications. But what we're just going to basically do is a few different types of examples for each one. Okay? Okay. Also, side note, I miss all of your faces, so I really hope that you come and join me in the tutoring session. Even if you don't need help, just say hi and then bye. But yeah, look at the schedule for your scheduled class time, and I'd be happy to help you with any Pearson questions or questions on the notes that we're about to take. Okay? All right, so I hope you have your notes all ready to go. If not, you might want to either print them out, upload them to OneNote, or copy down some of these problems. Only the ones that I highlighted are the ones that we're going to be doing. Cool? Okay. Yay, let's start. Oh, but before we begin, you know what we have to do. Yes? Okay, are you ready? Are you ready? I hope you do it with me. Nice and loud for your whole household to hear. Okay, here we go. Yay, math! Yay, math! Good job. I believe you. You did it, right? No, you didn't. That's okay, fine. I'm just kidding. Okay, so let's talk about volume of very basic shapes first, starting with rectangular prisms or cubes. They're so sorry. It's late. Rectangular prisms and cubes are not the same, so that's not what it's saying. But a cube is a special type of rectangular prism. A cube has all the same dimensions, so it's like a 5 by 5 by 5 cube, right? Rectangular prisms in general are not all the same. So you may already know this formula, and this is general for rectangular prisms. Length times width times height. Okay, so that's going to be like your generic formula to use, but that only works when you have the shape of like a box. Okay, so number one, for example, we would do length times width times height. So I don't know, 9 times 17 times 24. And you might ask yourself, well, which one, Miss Coffee, is the length and the width and the height? How do I know? I'm sure that's what you were dying to ask me. The answer is it doesn't matter in a rectangular prism or a cube, because you multiply them all together, you get the same number regardless. So, whichever one you want to say is a length, width, and height, you just multiply all three. And our units here are going to be centimeters cubed, right? So when we're talking about volume, that's going to be the third dimension. Yay! So it's this actual physical, how much space is being taken up, and that's always going to be unit cubed. So there's our answer. Easy peasy lemon squeezy. But you know, it can't always be that easy. I'm sorry. I wish it could. No, I don't, because that's no fun. Now let's do all other prisms. So this is the formula to use for all other prisms. Okay? So not like you have to memorize any of these, okay? I'm giving you all of these formulas, but you need to know what the variables stand for. That's important, okay? So all prisms in general are going to be, to find the volume, capital B times the H. But this capital B here is not just base. So you don't want to say, that's the base. No, that is the area of the base. And if you forget that little tiny fact, your whole world will come crumbling down. Just kidding. But really, it's an important distinction to know. Capital B is area of the base. Why is that important? Because in a prism, the bases could be anything. It could be a triangular prism, so a triangle base. It could be a hexagonal prism, so a hexagon base. It could be a trapezoidal prism. trapezoid base. So similar to the surface area lesson that we did, you're going to have different types of bases for your prisms, but they use the same formula in general. It's just that capital B changes depending on the kind of prism. So I'm going to skip down here and we'll do number 7 together. Okay, so we have, this is a triangular prism because these are my bases. Remember, base is not at the bottom. Base is going to be the two congruent parallel polygons or shapes. So this is a triangular prism. So to get the volume, we do capital B times height. Be careful here. The height is not just how tall it is. That's not right at all, okay? I know that's confusing, but it's just not. The height is the distance between the bases. So if those are my two highlighted bases, 31 is actually the distance between those bases. Not 28 is not the height. 31 is the height, which is weird, I know, but it is. Okay, then we focus on this, let's do blue. I haven't done blue in a while. Okay, capital B, remember, is area of the base. So if we think about what kind of base that is a triangle. So we're really trying to find the little arrow here, area of the triangle. So this highlighted part here, right? Well, how do I find area of a triangle? Well, you should know that. If not, go back to your 7-1 notes that we did, okay? Maybe reference those, or when you're doing your quiz, have those notes out also, or when you're doing your piercing, because you're going to need all those formulas. So area of a triangle is half base times height. Okay, this means base of the triangle, so that would be this right here, and height of the triangle, which would be this right here. So it looks confusing, right? Because you have two different heights. You have this height and you have this height. This is height of the prism, but that's distance between the bases. This is height of the triangle. So I'm going to put H triangle, and let's put B triangle down here so we aren't confused, okay? Base of the triangle. Okay. Ooh, but we don't have the base of the triangle, do we? We have this hypotenuse here. Interesting. But that's also going to be the same right here, 32.5. And since this is a right triangle, guess what we can do? You guessed it, our favorite theorem, Pythagorean theorem. So we're trying to find this base here. So we're going to call that, let's call that x. So we do 28 squared plus x squared equals 32.5 squared. Pythagorean theorem. Okay, now we need our handy dandy calculator. So 784 squared. Ooh, 32.5 squared is 1056.25. Then you're going to subtract 784. You get 272.25. This is fun. Take the square root of that, and x is 16.5. Not too bad. Okay. That is the base of the triangle, which means I can plug it into the formula for area of the triangle. So we're going to go back over here. Capital B, area of the triangle is half 16.5 times height of the triangle. Be careful. That's 28. Okay, so this is multi-step. Times 28. Thank you. Divide by 2. So capital B is 231. And now that I have that, I can calculate the volume, which is just going to be plug and chug. I'm going to go down here though. Volume is 231. Height of the prism is the distance between the bases. So we multiply that, plug in 31, multiply those, and you get 7,161 kilometers cubed. Boom. Done. Geniuses. Okay. We're not going to do number 8. Okay, so does that make sense? I know it's a lot of steps, okay, but it's not stuff that's new to you. The only new thing is here's a formula that I'm not making you memorize. That's the only new thing, is plugging it into a formula, right? But the Pythagorean theorem, area of a triangle, you already know all of that. Okay, so you can do this. Let's talk about cylinders. I like cylinders. Again, they're not too bad. Volume of a cylinder is really the same thing, but the capital B, the area of the base, is always going to be the same thing, whereas in a prism, it changes. You could have a triangle, you could have a hexagon, you could have an octagon. In a cylinder, it's always going to be a circle. And so area of the circle is pi r squared. That's it. Multiply area of that by the height of the cylinder, and you got your volume. Okay, so let's do that right here. Ignore this oblique thing. We're going to come back to that in just a minute. Okay, we're going to do this example together. So, pi r squared times the height. Pi 18 squared times the height. Look at that. Not trying to trick you. Not trying to do anything fancy. That's going to be 4,860 pi. And that is in terms of pi, which is how I like it, like on the quiz. So when you're doing the quiz, you'll see the multiple choice options are going to be all in terms of pi. But if the Pearson homework says to round your answer to the nearest whole number or a tenth or whatever, it says the word round or approximate, you want to type in the pi. So if I do 4,860 times pi, that's 15,268. We'll round to the nearest tenth. So 0.1 inches cubed. So either one of those is correct depending on how the instructions are worded. Okay, that is called, this in general over here, this type of cylinder, it's actually called a right cylinder because the height is going to be perpendicular from base to base. From the center of one circle to the center of another circle is going to be a 90-degree angle. That's what makes it a right cylinder. However, you're going to see on the homework a couple weird looking cylinders. They look like this. Circle here, oval thing, goes like that, goes like that. Okay, guys, this is called an oblique cylinder. It's like the Leaning Tower of Pisa, okay? You take a cylinder and you just lean it over or you slant it. That's called oblique, and the difference is, obviously it's slanted, but more specifically, when you draw in the height, it's actually outside of the cylinder. Whereas right cylinders, the height is going to be like it's usually drawn here on the edge of the cylinder. You can also draw it inside. But if I were to try to draw the height inside here, notice how that's not a 90-degree angle. So that's not the height. This is the height. And the radius would still be this little guy right here. All right. So if you see a cylinder that looks like that, please don't freak out. It's the same exact formula. It's still pi r squared times the height. It is the same thing. It's just slanty. Okay? All right. Let's see if we have time for this one. This isn't too bad. I'll kind of go really fast and maybe do part of this. Basically, this is a composite figure where you have a prism and you have half of a cylinder. So you find the volume of each and add them together. This one on the left is actually a rectangular prism, so that's going to be a pretty easy one, which is length times width times height. So this might be our width, maybe this is our length, and then our height is this, which is also conveniently 4.5, only because it tells me that right here. So that's going to be 4.5 times 4.5 times the height, 10 or whatever, okay? And you just add that to your cylinder, which is pi r squared times the height